Welcome everyone, my name is Tomasz and I'm a member of the .NET community. Today we are going to talk about Azure Functions, but before that let's just answer some basic questions. So what are those and what is Microsoft Azure in the first place? So as we can read, Microsoft Azure is a set of cloud services. If you had some experience with Google Drive, Gmail, or Microsoft 365, all of those are basically web applications provided to us by Microsoft or Google, and they are perfect examples of cloud services because they are ready to use. We are not troubled by configuring them, maintaining them. They are offered to us as a cloud services, so we just use them. Everything else is handled for us. And Microsoft Azure is nothing more than a bunch of such services, although they are a little bit more complicated than examples I have given to you. Azure Function is one example of such cloud service. So Azure Function, as we can read, is a serverless, stateless piece of code which is going to be run by a trigger. So what does this keywords means? Serverless, it stands for that we do not have to have any kind of hardware on our side to run Azure Functions. Everything that is needed is provided to us by Microsoft Azure. In terms of stateless, well, it basically means that everything what is going on outside of scope of our Azure function is not of our concern, because uh, what is matter to us is that we run our function, start our function, we wait until it executes, it executed, and we are done. We are not concerned about anything else. As for the last part, run by a trigger, Azure Function can be triggered by multiple sources. Those are examples of many ways to run our Azure Function. Well, most of them, like this Azure Blob storage and other means, are basically fully fetched Microsoft Azure services. So we are not going to talk about them because they all deserve their own presentation. So for today, we are just going to focus on the most basic one, HTTP trigger, which allows us to run our function once we send a request over HTTP, much like an API call. In fact, we are going to create some basic HTTP triggered Azure function. But before that, let's just create a simple ASP.NET API application, which will going to respond on our requests. So let's just go to the Visual Studio. I already prepared some blank solution, and we are going to create our first project, and that project would be an ASP.NET Core web application. I will just stick with the solution currently provided, leave the default project name and hit create. Once I choose the API template for my application and hit create, Visual Studio will scaffold the project for me, and we can just run it to prove that everything is working just fine, and we will see the basic results of that application. So let's just give it a moment for Visual Studio to think it through. And we should have the web browser opened, and the browser will call our API like that. And for that request, we have this response. So this is basically some random generated data from our application. We can just go there to the controllers, weather forecast controller, and as we can see on a get request, all what we will get is some random values of temperature, and we are going to get 5 elements of those. So next, let us create another application. This time we will create Azure Function application, and as in the previous example, we are going to just scaffold the default project. So let's create some project in our solution. Here, as we discussed on the slide, we have an ability to select multiple triggers from multiple triggers, and we'll just go with the standard HTTP trigger. We're going to hit next, and Visual Studio will scaffold for us the entire project. We can run it. Let's just switch over to that project. Hit run. And basically what we are going to get is a process that will await for our calls. So we can go to our Postman and select some basic API call like that. Let's just send this request to our application, and we see some response with OK status. The HTTP trigger function executed successfully, but we need to provide some query parameter for it. And as we can see, our function is able to produce multiple responses. Here is the response we got because we didn't provide a name parameter. But for now, let's just leave it like it is and open the controller side by side. And let us examine the difference between those two applications. So as we can see, if we run the first application and the second application side by side, let's just run the first one and the second one. The first thing we can notice is that those addresses for both applications are different. This is the valid HTTP address for our ASP.NET application, and this is another address for our Azure function. Well, basically they are different in some way, so we would like to have them both be the same. This is the result from our ASP.NET Core application. This is the result we already got from our Azure function. So first, let's just focus on having these two strings to be exactly the same. So let us go back to the Visual Studio, and first thing we can notice is that this function on our left side is getting its route function 1 from this function name. So basically, the idea about this is that if we are not going to provide any route parameter, the default route for this function will be the function name with the API prefix. So in order to fix that, let's just grab the controller name. Again, this is some convention that our ASP.NET Core Web API will respond to the routes based on the controller name. So we can just change it right here to match the API weather forecast. And here we just provide the weather forecast as well. Let's just save those two applications. Let's just stop both of our solutions and let's just rerun them. So here is our Azure function, and as we can see, we can now call it from this API, from this route. And as we can see here, if I'm going to execute again this request, I will not get any response. And if I move to the next example with the valid request route, I will get some response from my function, and the same from the ASP.NET API. So we have basically both these paths to be matched. So we can go to the next example. Now, as we can see, our Azure function can be called both with get request and post request. But we cannot tell the same for our ASP.NET API. So the reason why we can do it is very simple. Here in the HTTP trigger parameters, we allowed it to run both get and post methods. So let us just remove it. Here also as well we have some authorization level. We can change it right now to anonymous, and here we can just do the same, just paste the allow anonymous attribute. It's a default attribute for this get request method, but now those attributes match exactly this attribute. So we can again save both of our solutions, stop the first application, stop the second application, run them one more time, and as we will see in a couple of seconds, our Azure function will no longer be able to listen to the post requests. Yeah, as we can see here, our function is now able to only accept these get requests. You can click send. And I get no response. Exactly, not found. Okay, so the last thing what we are going to do is to force our Azure function to return exactly the same results as our ASP.NET Core application, because right now those responses are very different. Yeah, because here we get some data and here we get some response. Well, the reason for that is, of course, our code is different. For example, if we are going to run our Azure function with a query, with a name parameter and hit send, we are going to get some response. Hello, Tomasz, this HTTP triggered function executed successfully. Well, because this is what the function is expecting from us. It will get the query parameter, will deserialize it to an object, and give us that response or the other one. So basically, to force this function to the same, we are just going to grab the entire method body method from that get request. Let's just replace it like that. Let's just add some missing statements like summaries. This is just an array, so I will just grab it and copy it. Now we have to scaffold our class, make it public, and that's it. Right now, if we are going to run our function, let's just stop it right from here. Okay, it starts spinning, and we should get the valid response. So that's all for this example. Let's just go back to our code. Let's just close this solution and get back to our presentation. So that was the example of the Azure function. As we can see, it's not too hard to just create the first simple Azure function. But what good it will provide to us if nobody else will be able to use it. So now we are just going to deploy our solution. So in order to do that, we have to go to Azure Portal. And the base idea about what we are going to do is that Azure Function, Microsoft Azure is subscription-based platform. So I will deploy our solution to my subscription to one of resource groups I have created earlier. And the resource group is nothing more just a bucket for all the resources you can see here. Yeah, this is our resource for Azure Function. So let's just go to the Microsoft Azure portal. Let's just log in. Now the easiest part is that if I go to my resource group, let's just select this one, go to my Azure Function resource, and here of course there are no functions yet. I can just hit this button, get publish profile. And what I'm going to do next, I'm going to go to my Visual Studio, hit right button to my Azure Function project and select publish. Right now I'm going to just import the profile I have downloaded from my Microsoft Azure portal and hit publish. So it will take some time. In the meantime, I will show you how to create this Azure function from the portal itself, because publishing from Visual Studio is just one method to do it. So let's just create a new resource. Here we can just simply select function app. Or the question is, it's going to load or not. Okay, now we are going. Here, this is the basic configuration. I need to select resource group. I will just create a new one, call demo resource group for Capgemini. Hit OK. Now I just need to select some app name for my Azure function. Let's just go with the same. So demo function app for Cap. Select run stack. I will go with .NET Core. Region, I can select some region that is closest to me. Let's just stick with Central US for now. And this is basic everything what we need to do. We can go through the entire configuration, like select operating system, like consumption plan. This is the basic the configuration that will tell us how much money we will go to spend on this Azure function. And let's just hit review and create. So it will take some time for this function to be created. Will be noticed once it is ready. For now, let's just go back to our Azure function that we have deployed already. As you can see, we have published one succeed. So we can go to our Azure Portal, select our function, and as we can see, we have our function already created right here. If we have our function 1. So I can just grab the code from here. I will click get function or URL. I will copy it. I'll create another browser tab and I can just go to it and I will get the response that we already know. Yeah, if I hit refresh, I will get some new random data. And this is our API full path for our function. If we go to the root, we will end up with this funny site. So we are waiting right now for our Azure function app to be created. In the meantime, we will deploy we have deployed our function app, and in a second we are going to create the same function app within the portal. So we already use Visual Studio. Now let's just cover in portal option to create this function. So let's just hope that this resource is already created. Yeah, it's been created for us. So let's just hit go to resource. And from here, click the plus button. As we already seen in our presentation, we can choose either some IDE and then publish our method, or just stick with in-portal method, select the trigger which we want, and just hit create. And in a couple of seconds, our Azure Portal will scaffold nearly the same code for us. And here we can just, again, copy the URL for it. We can even write some tests for our function. Yeah, as we can see, if I will go to run it, I will get this response, hello Azure, and if I remove any parameters, I will get another response. So basically, this is the same behavior that we already seen. So let's just move forward. Now, as we've seen in a previous demo, we end up with an application that will give us some random data. It would be a good idea to just switch over to some consistent layer, for example, a database. In case of ASP.NET, we chose Entity Framework Core. It will not going to talk about it now because we want to focus on Azure Functions. In terms of Azure Portal, as we already see, we have a variety of services to choose. One of these services is Azure Cosmos DB, which serve as a NoSQL database for Microsoft Azure. So let's just go to the example. I've already prepared some. So let's just open another solution. And here it is. Let's just close all of those windows and go with HTTP trigger weather forecast function. And now our goal is to basically write two functions. One function, well, basically one function, but the first behavior of it will be to, with the HTTP GET request, just return some objects from database, like weather forecast in, and if we are going to hit the same URL with the post method, we are going to generate how many weather forecasts and add them to the database. The way it is working is somehow connected to the second topic we are going to talk about, Azure Function bindings. So we can just instruct our Microsoft Azure function to grab some data from multiple services provided by Azure and instruct it in the same way to output our results from the function to some other Azure services or even some outside services, as we are going to see in the last example. So as of now, we just asking the Cosmos DB, this is our NoSQL database, to connect to this database, to this collection of weather forecasts, and just execute the SQL query, select all from our collection. And the result will be a list of weather forecasts of our object. So this is the first parameter, and the second one will be marked with the same attribute Cosmos DB, but this time we are going to use another object like async collector, and as the name suggests, it will just collect the documents, objects that we are going to store in the database. So as we can see here, we have a for loop that will just add asynchronously up weather forecast to the database. And if you are going to run that function, maybe even let's just set up some breakpoint here and go to our Postman. We can close those. Yeah, and the idea is that we can run our Azure function get request. We should get a breakpoint here so we can go through it. As this was a get request, we just return the result from the database. As we can see right now, we have no results. And if we are going to hit the same API with the post method with some additional parameter, how many, we will create 3 new entries in our database. So we go through, we go into this if statement, and for each how many data, we'll just add them to the database. Now just let us run one more time the get request. Again, we're going to hit the breakpoint, and as we can see, we already have some data in it. Yeah, so this is the very powerful way of using input and output bindings. And as we can see in the third example, we can go even further with that because we can create some bindings like that. So in this case, we have a trigger HTTP. We grab some input from our Cosmos DB and from some other Azure services. In this example, Blob storage. This Blob storage serves like a file repository, but all those data will go as an input bindings to our Azure function, and our Azure function will call SendGrid services, which is responsible for sending emails, Twilio service, which is responsible for sending to us text messages, and some other queue service, which is responsible for, in this case, just triggering the second imaginary Azure function. So let's just go back to the example. Let's stop that services and offer another solution. This would be the last one. And here we are. Let's just run this to see how it works. Because as we can see, the code is actually really simple. Yeah, this is all the code we need to write in order this solution to work. And all the magic is happening during the initialization process with the inputs outputs binding and triggering the function. So what we are going to use is the HTTP trigger with the post request. We're going to send with the root parameter a GUID parameter, which which next is going to be used with Cosmos DB. This Cosmos DB will ask our invoice DB and collection of items invoices to grab some metadata about our invoice with this GUID, as we can go to our Azure Portal, select the proper Azure resource group and go to our Azure Cosmos DB. Let's just open Data Explorer. And as we can see, we have a invoice DB. Oh, there's an error right here. Okay, but even if we couldn't get any results from Azure Portal, it's some kind of a bug of the Azure Portal for now. We can still go to the blob storage and the blob attribute. This is the input binding. It serves the same purpose as a Cosmos DB attribute. It will just give us the invoice of that ID from the Azure Blob Storage with that connection. So if we go to the Azure Portal one more time and go to our resource group, go to our storage account, hit Storage Explorer, go to Blob Containers, we can see invoices, and here we have some. Oh, we do not have any documents. We can just add them right now. So let's just go add some data. So I already have some script prepared for it. I go to final HT process and run init data script. It will ask me in a moment to log in to the Azure portal, and it will add the data for me. So right now, if I'm going back to the Azure portal, I will just refresh the data. I have my invoices here. And if I will go to my Azure Cosmos DB, I should have the same data stored right here. Yeah, and we already have these items. So the main idea about our function is to grab those details, and with this pair of output bindings, we will going to send an email and we're going to set a text message from this number. As we can see, both of these parameters are async collectors, so they are going to just collect the objects we are going to use. And if we send some request with the proper ID of the invoice, I'll just hit send. And if all goes well, we should see that our Azure function is already sent an text message. And it should also send some email for me. So let's just check if that email is already there, and it's here. We have some invoice, and we even attach the invoice in our email. So we can just go ahead and open it. Yeah, and it is of course not the only possible way to configure our solution. We can go with that solution and we can with that solution. So basically our Azure Functions allows us to construct any process we want and then just upload to the cloud. And well, that's it. I think it's a very powerful solution. So I will leave you with that. Thank you for your attention. See you in the next presentation.